Okay, room 16, welcome back. We're going to do another lesson on statistical measures. Hopefully you have your math journal with you and a whiteboard. That will be helpful. We're going to start by looking at the topic today. It's mean absolute deviation. Yes, I know that sounds very daunting, like it's going to be difficult, but it's not. There are a lot of steps to it, but they're all easy steps. So I'm going to teach you really quickly today just about mean absolute deviation. So first thing, get out your math journal. Let's write down this definition, then we'll talk about it a little bit. It is the average distance between each data value and the mean in a data set. I know, write that down. Probably doesn't make a lot of sense yet, but it will. Okay, let's start by breaking apart what it is. Okay, the mean. We've already learned what the mean was. We worked on our statistical measures. We talked about range, the distance between the biggest piece of data and the smallest. We talked about the median, the one in the middle. We talked about the quartiles, first and third, the interquartile range, outliers, and we also have talked about the mean. That is the average. Add them all up, divide by how many numbers there are. Okay? So the first thing we're talking about is the mean. We're going to find the average. Then the absolute deviation. Okay, this word right here, deviation, means how far does it deviate? How far is it from the mean? How far is it from the average? Okay, and then we have this word absolute, because earlier in the year we've talked about absolute value, right? Absolute value is always what? What's absolute value always?
It's the value of any number, no matter if it has a negative or positive sign.
Okay, so it's always positive. It's the distance from zero, right?
Mm-hmm.
So when we talk about absolute value, and we're talking about mean absolute deviation, it's always going to be a positive value. It's always going to be how far is it from the average. And if it's below the average, we're not going to say negative. We're going to say it's, this far below the average. And if it's above the average, it's going to be positive too. It's just how far is it from the average. So that's why we have this phrase, mean absolute deviation, that we're talking about. We're talking about the average and how far does it deviate from it, okay? All right, so let's turn this around. The best way to do it is just start looking at a problem and see if we can work it out. All right, on your whiteboards, we have a problem here. It says the number of daily visitors to a website. Okay, so we've got the number of daily visitors to a website here. The first thing we have to do in mean absolute deviation is find the mean. We've got to find the average. Okay, so we want to find the average here of these 5 numbers. 112, 145, 108, 160, and 122. How are we going to do that, Colby?
We're going to add all of them up and then divide by 5 because there are 5.
Perfect. Go for it. We're going to add those all up and divide by 5. First thing we have to do is find the mean or the average. Okay? Use those little math tricks. Make sure you're lining up your numbers. Make sure you counted how many numbers you had and how many you have on your list you're adding. We don't want to make a silly mistake. Okay, you don't need to go past hundredths. You can just go to tenths if you want. Oh, cool. Tenths works.
Yeah.
Okay, so we found our mean. You both found it. What did you find? Dalton?
129 and 4 tenths.
Colby, is that what you have?
Yes.
All right. So we have 129.4 or 4 tenths. That is our mean. Now, we want to figure out the mean deviation, the absolute mean deviation. What we have to do now is subtract all of our values and the mean. Okay? Now, the mean usually fits right in the middle, right? We didn't put our numbers in order from least to greatest. It would always be helpful to do that. But what we have to do now is figure out our difference between our mean and each number. So, Colby, if I'm going to figure out the difference between 129 and 4 tenths and 112, how am I going to do that?
We're going to subtract 112 from 129.4.
Right, exactly. So, whether you have a calculator, it's fine to use a calculator for this. If you're doing it on paper, 129 and 4 tenths, okay? Subtract the 112, it is smaller. Make sure you put yourself a decimal and a 0, right? So you line them up correctly. Okay, we are going to find the value of deviation. How far is this from the average? How far is this one from the mean? How far is this one from the mean? Okay, so Dalton, how am I going to do that with 160?
You just do 100, since 160 is greater than 129 and 4 tenths, you subtract 129 and 4 tenths from 160.
All right, yeah, you just turn it the other way. So in this case, it's going to look like this. 160.0 minus the 129 and 4 tenths. Again, that's why we call it the absolute value. We're just trying to figure out the distance it is from the mean. Okay, this piece of data, how far is it from the mean? That's this whole idea of mean absolute deviation. Now, here's the thing. I don't have a lot of room on my whiteboard, but on your whiteboard right now, what I want you to do is I want you to find out the deviations on 1, 2, 3, 4, 5, all 5 pieces of data. So you're going to come up with 5 new answers. Okay, we already did one. It was 17.4. Is that what you got, Colby?
Yes.
Okay, 17.4 right here. That's one of our pieces of data. Okay, I'm going to erase this real quick, and so I can write it a little more clearly for you, and you can see it. Okay. While you guys are working on that, I knew that my mean was 129.4. Okay. I know that my variation for this one is 17.4. Okay, let's get some of our other variations here. To speed this up, we can use a calculator. Okay, just for time's sake. And you can use a calculator on this. When you even take this problem on the state test or whatever, they'll let you use a calculator. It'll be offered in the upper right hand corner. So there's no problem with you using a calculator. Again, these are not difficult problems. Subtracting 145 minus 129 and 4/10 is not difficult. But are there a lot of opportunities to make a simple mistake? Yes. That's what you have to be careful on. Because if I wrote 21.3 right here, it's going to make the whole entire problem wrong on one simple mistake, of 1/10 of a point there. So anyways, you got to make sure you get all of these right. Okay, that was step 2. Step 1, find the mean. Step 2, find the deviation, the difference between the mean and all the pieces of data. All right, now we're on step 3. Find the mean of your new data. So Dalton, how do we find the mean of this?
Add all of the deviations up and then divide by 5.
Yeah, that's it. You're just finding the average again, or finding the mean again, but you're finding it of the deviations. Okay? So we're going to add all 5 of those up, divide by 5. Good. Now what are you going to do, Dalt? You added them all up, now what?
Now you divide by 5.
Yeah. Okay, hopefully at home you're doing this on your whiteboard. You can use a calculator, either way. Hopefully your total is right there. Okay, Colby, you add them up? Okay. So, Dalton, is this what you got?
Yeah.
Awesome. All right, so what does that mean to you? Like, if you were explaining that in 6th grade terms, okay, we got 18.48. That's the mean deviation. How would you explain that in like 6th grade terms? Think about the number of daily visitors to a website. What does this piece of information tell me?
Well, if you add all of them up, I'm just going to go step by step. So if you add all of them up, that's the total, and if you divide that by 5.
Okay, we already got the average.
Yeah,
So first, let's talk about that piece of information. This piece of information, 129.4. If you're going to put it into words about the daily visitors to a website.
The average per day was 129 and 4/10.
All right. So on average, we get 129 visitors to our website. This day we had 160. This day we only had 108. Okay. So you can see it varies. Now, thinking about that, what does this piece of information tell us?
It's the average of the average.
Okay, it tells us what we're trying to say is, in 6th grade terminology, is it just shows it how much it varies. Okay? How much it varies each day. Okay, so it fluctuates. If I'm looking at my website and say how much does it fluctuate? Well, it fluctuates about 18. Okay, above and below. All right, as we get older, we will put a plus or minus right here. Okay, plus or minus 18.48. What that really tells you is it could be that much lower or that much higher, but it's still just an average. Does that make sense? It's a mean absolute deviation. So, in all honesty, if you think about this website, does it vary very much from day to day? Not really. Only 18 people? Do you see what I'm saying? Okay, that's how many visitors I have. It's only about 18 different, from day to day. That's not a very big variation, right? Let's think about another website, and let's say hardly anybody uses it, and then on the weekend, it gets thousands and thousands of hits. I don't know what kind of website that would be, but do you understand? Would the variation be a lot different?
Mm-hmm.
Yeah, maybe during the week they get very few, and then on the weekend all of a sudden the website just goes crazy. So that would have a lot more variation, wouldn't it? This one's pretty consistent, we would say. Okay, it doesn't have a ton of variation. Okay, the plus or minus 18.48. All right, let's look at a totally different, same exact type of problem, but we're talking about water slides. The height of the water slides at Wildwater Bay. Okay, you guys can think about, we don't call it Clovis Lakes anymore. What do you guys call it? Wildwater Adventures? Yeah, Wildwater Adventures or whatever it's called. Ours is a little different. But anyways, here are your 5 water slide heights. Okay, first thing we're going to do is what, Colby?
We're going to find the average.
We're going to find the mean. We're going to find the average. All right, go for it. Okay, what do we get for a mean?
I got 116.6.
Perfect, that's what we all got. All right, 116 and 6/10. Now, what's step 2? What's step 2 that you're going to do?
To find the absolute deviation.
All right, we're going to find the absolute deviation. Dalton, how are we going to do that?
You're going to subtract 120 or 108 and all the numbers and 116.
By the mean. All right, let's do it. Go ahead. I should have 5 new pieces of data. Now, if you notice me, I like to write it right underneath. Okay? I like to write my deviations. If I write out my problem, I'm going to write my deviations right underneath so I can keep track of them really clearly, make sure I have the right number, all of those type of things. Okay? Again, just for time's sake, so this video is not too long, I'm going to do mine on a calculator so we can move on. If you're at home, you can push pause or whatever you need to do to catch up. Okay, real quick, I'm going to stop you for just a second because I just want you to think about something. Just by looking at these deviations right here, or looking at these numbers, which one of these problems do you think is going to have the bigger deviation? The top or the bottom?
Top.
Okay.
Maybe the deviation. Bottom. The bottom.
You think this one's going to have the bigger deviations?
Yeah. Yeah.
Okay. Okay. You think, because which numbers, we got 3.4, 8.6, 22.6, 18.4, 9.4 are deviations. Up here, 7.4, 30, 21, 15, 17. Think it's going to be the bottom?
Well, I'm not exactly sure because you have 30, which is really big, and then you have 7, which is really small. But then you have like 3, which is really small, and 22,
Right.
which is really big.
Right, but 30 is bigger than 22, right? And 3 is smaller than 7. Okay, let's figure it out, and then we'll know. Okay, figure it out, and then we'll know. But I want you to be able to think about that on the front end. Good job, Doll. Alright, so our mean absolute deviation on this one was 12 and 48 hundredths. Plus or minus 12 and 48 hundredths. Colby, you're going to get that too because you've got 62.4 divided by 5. Yep. You're going to end up with 12 and 48 hundredths. Okay, back to our question, Dalton. Which one had the least deviation?
The bottom one.
Yeah, the bottom one. When these were a little bit smaller, you didn't have anything this big, okay, and it didn't have anything this small, you knew this one was going to have less deviation, okay? So the deviation here that we're thinking about is we're thinking about the height of the water slides, all right? They're all within about 12 feet of each other, plus or minus 12 feet of each other from the average. Does that make sense? So that makes sense. You wouldn't have one, slide super, super high and then one super, super short, really. All of these are pretty
The average of the distance from the average.
right. It's the average. All right, I got one more problem that we're going to do, and that'll be it for mean absolute deviation. And I'm only going to show you this problem just to try to help it make a little more sense to you. Okay, we're just going to do these two sets of numbers, okay? And there's a reason, I'm going to stop you in the middle of them, and there's a reason that we're going to do these two sets of data. Okay, this one, 19, 20, 20, 21, 22, and 24. Okay, I want you to find the absolute mean deviation for this set of data. Okay, then I also want you to find it for this set of data. 1, 5, 7, 13, 25, and 75. Okay, start on the top one. Step number 1, find your mean. Step 2, you're going to subtract all your data values by the mean. Okay? And step 3, you're going to find the mean of your deviations. Okay? Of those differences. You're going to find the mean of those differences. Okay, that's for the first one?
Mm-hmm.
Okay, awesome. Do it for the second one too. My first question though, what was the mean of this first set of data?
21.
21, okay, perfect. Okay, find the mean of the second set of data. Yeah.
For the
Average of the deviation on the first one?
yeah.
That's what you got?
Yeah.
Okay. I think Dalton got something different, but that's okay. Let me check it for you guys. you're right, Colby. I think Dalton missed it somewhere. Oh, hey, hold on. What is, how many pieces of data are there? 6. You didn't do, you might not have subtracted this one minus it because it's 0,
Oh,
but you still need it. Does that make sense?
yeah.
In your average. Okay, good. That's what we're working on. You didn't subtract it by how many there are, right?
No, I did, but I thought the mean was 20. That's
Oh, no.
what I did wrong.
Okay, no, yeah, the mean is 21.
Mm-hmm.
Okay, that's right, Colby. Okay, now, what was the mean on the second set of data? Have you got there yet?
Yeah, no. 21. Well, I could. It was 21.
It was 21. Oh, well, how's that possible?
Because
This average is 21.
I know, but the 75 and the 1. Yes.
Colby, figure this out. Tell me if this average is 21.
Okay.
Okay, what I wanted you to see here is that we have 2 totally different sets of numbers. Okay? This one has a 75, a 1, a 5, 7. But what is the average? What is the mean?
21.
21. The same exact average as this set of numbers. Okay? So, now when we're looking at that though, now which one of these sets of numbers, Dalton, is going to have the greater deviation?
The bottom one?
The bottom one, because it has a really big number and a really small number. Okay? So you could say, oh yeah, our average was $21. Okay, I just put dollars in there for you. Like, let's say this was 6 different kids in your class, and this is how much money they had today. Let's get at 75. What's he doing with $75? I don't know. But if you said, oh, on average, the kids have about $21. Well, these kids on average have about $21 too. But you can't really tell, you know, who has how much unless you saw this deviation. That's just one way to think about it. So we have the same exact average, but this set of numbers, the mean deviation is only 1.3. So that tells you the numbers are what? Very what?
Very
Close together. Very tight and close together. This deviation is 19.3. So that tells you the numbers are what?
very far apart.
Spread apart more. Okay? The average deviation is 19. They're spread apart by 20. So you can see that even though they had the same average, okay, the deviation was much different. Okay, these numbers you could tell are very close together because it has a small deviation. These numbers are really far apart because that has a much bigger deviation. Okay? All right. I think this will get you through the couple of worksheets that we have on absolute mean deviation. Next time we'll work on how we graph these and some box plots and some dot plots and stuff like that. All right, see you next time.